Welcome to video number 42 in the Using iTrain tutorial series. My name is Bob. In this tutorial we look at the effect that the percentage chance of a wait has on automatic routing without a route. Welcome back. We saw in tutorial 40 that the Station Blocks tab contains a variety of additional parameters that can be specified for blocks contained in a station. And we used our truth table as a reference which described the outcome of each combination of tick boxes for the wait, length and pass parameters. And the different combinations produce different outcomes when we are running automatic routing without a route. The percentage chance of a wait, which is found in the Train Types tab, also has an effect on the outcome of automatic routing without a route, and that is what we're going to look at in this tutorial. It's a great feature for adding variety to our layout operations and is very commonly used by iTrain users. But it's easy to forget that it is in operation, and it often leaves us wondering why iTrain is behaving in a certain way. In this tutorial, I hope to explain what is happening and why. So here's the layout we're going to use. Station 2 is just a station that the train will start from, and Station 1 is set up for in order block selection, with the blocks set up in this order, so B1 then B2. The station is set up to receive all train types that can wait, and the percentage chance of a wait is currently set at 100%. And we will be using this train called D6510, which is a local passenger train. So when the percentage chance of a wait is set at 100%, any specified wait will always be active each time iTrain is selecting a destination block in the station. If it is set to, say, 50%, this means the wait is active for only 50% of the times that iTrain selects a destination block. The significance of this is in the way it affects how iTrain selects the destination block, and specifically whether the block selection method is active or not. You may recall from the tutorials about the various block selection methods that the block selection field is only active when multiple paths are available in the station and when the wait is active. When these two criteria are met, iTrain applies the rules for that particular block selection method. If the criteria are not met, iTrain randomly selects the destination block. So let's see it in action and see if we can explain what is happening. I'm first going to set up the blocks so that B1 has all its checkboxes unticked. And B2 has the wait, length and pass ticked. If we look at our truth table, that says for B1, iTrain will never select a path that contains this block. And if we look at the configuration for B2, it says iTrain may select a path containing this block whether a wait will occur or not, but will only wait if the train fits into the block. For this first example, we will set the wait to 100% so that it is always active. And remember to press the OK button before we leave to save the settings, and don't simply close it down, otherwise the settings will not be saved. So click OK. And when we press the start button, we see that iTrain is consistently selecting B2. Why B2? Well, we can quickly explain it by saying that there is no wait active in B1. So iTrain selects the next block in the list, which is B2. B2 has a wait that is active, so B2 is selected. And that explanation is okay for a general understanding of how to use iTrain. But there is more to it than that. And the more we understand, the more creative we can be with using iTrain. So let's look into it a little deeper. We know that automatic routing without a route works on the principle of seeking stations, and when multiple stations are reachable from the current train location, iTrain will randomly select one of those stations, and then it randomly selects a path to that station when multiple paths are available. In our little example here, there is only one station that it can reach from its current location, and there is only one path that it can take to the station. So we need to imagine a more complex layout with multiple routes to the destination and many blocks and turnouts that it may have to cross to get to the station. What is not so obvious is that iTrain does not make the decision about which destination block it will select until it actually reaches the station. When you think about it, that makes sense. With automatic routing without a route, iTrain does not know the complete route that it will be taking before it leaves the start point. Why? Well, because it randomly selects a station to begin with, then it makes random decisions about the path it will take as it travels along the route. Therefore, it doesn't yet know how it will be approaching the station, so it cannot select the destination block until it is closer to the station. In our very simple example here, that destination block decision will be made when the block reservation, that's the yellow track that we see displayed in front of the path, when that block reservation reaches this turnout. And you can imagine that in a much more complex and longer route, that decision point could be many blocks away from the start position. So iTrain selects a route and the path it will take in that route as it travels along the route towards the station. And then when it detects that it has reached the station, it then has to make a decision about which destination block to choose. In our example, when it reaches the turnout, it sees that there are two paths ahead that lead directly into the station. So there are multiple paths, and at least one of those paths has a wait that is active. That meets the two criteria that tells iTrain it then needs to use the block selection field to tell it how to select the destination block. It sees that in order is selected, therefore it needs to apply the rules for in order block selection. The first block in the list is B1. iTrain needs to be entering the block in the direction next, which it will be. So that satisfies the direction test. But no wait is active. So iTrain cannot select B1. And we can see that summarized in our truth table. Here is the combination, all unticked. If we look here, it says iTrain will never select a path that contains this block. So iTrain looks at the next block in the list, which is B2. The train would be entering the block in the direction next, so that satisfies the direction test. A wait is active. It needs to test the length of the train to check that the block is long enough to accept the train. That test passes, so all the checks are okay, and iTrain selects B2 as the destination. And again, we can see a quick summary of that in the truth table. Here's the combination, and it says iTrain may select a path containing the block. Whether a wait will occur or not, but will only wait if the train fits into the block. So that is the operation when the percentage chance of a wait was set at 100%. Block B2 was consistently chosen as the destination block. Now let's see what happens when we reduce the percentage chance of a wait. Let's set it to 50%. This means that when iTrain performs the selection of a block, 50% of the times that it makes the selection, wait will be active in the blocks where wait is ticked. So the table will behave as it is shown here. and we have just seen the explanation of how that operates. But the other 50% of the times, the wait will be deactivated. So effectively, the table will look like this on those occasions. When the block reservation reaches the turnout, it sees that there are two paths ahead which lead directly into the station. So there are multiple paths into the station, but none of those paths have an active wait. That does not meet the criteria for iTrain to use the block selection field to choose the selection method. Therefore, iTrain will randomly select a block ahead. If it selects block B1, it effectively sees this combination of tick boxes. And when we look at our truth table, that says iTrain will never select a path that contains this block. So a path containing B1 is never chosen. If it randomly selects B2, it effectively sees this combination. And a quick check of our truth table says that iTrain may select a path that contains this block, but never stops, and the length test is redundant. So iTrain selects the B2 path, but passes through the block without waiting. So let's see if that actually happens. I need to remember to recheck this particular block and just recheck that I set it to 50%. Yep, so we'll press OK to save it and not just click here, otherwise it doesn't save the changes. So we'll click the start button and we see that B2 has been selected on this occasion. So when iTrain was randomly choosing the percentage weight of chance, on this occasion it must have made the weight active. So the block scenario would be looking like this. Let's stop the route and start it again, and this time we see that B2 is selected, but it will not be stopping because the block symbol is not orange. So this time iTrain will be passing, or the train will be passing through the station without stopping. And you notice that if I keep doing this, B1 is never selected. The other way to tell if the train is going to stop in the block or not is to look at the info window down here. So let's try that. So here we see it is stopping and waiting, and the destination block is actually shown here in the info. Now if I keep doing this until the pass-through is shown, we can see we're passing through and no destination block is actually indicated, which shows that it will be passing through. Let's try another combination. Open the properties, and this time we will tick the pass in B1, and we'll first see how it operates when we are at 100% weight. And remember, we're going to save the settings by clicking OK. So with 100% weight, let's see what happens. Well, we can see that as expected, it is consistently choosing B2. And that is for similar reasons as we saw with the first example. The fact that pass is ticked here is irrelevant because the block is never selected when the weight is 100%. Now let's reduce the percentage chance to 50%. So now 50% of the times that iTrain makes the block selection, the route will behave as before because the table will look like this. But the other 50% of the times iTrain makes a block selection, the blocks will effectively look like this, with the weight deactivated. When iTrain reaches the turnout here, when the reservation reaches the turnout here, it sees that there are two paths ahead that lead directly into the station. So there are multiple paths into the station, but none of those paths have a weight that is active. That does not meet the criteria for iTrain to use the block selection field to choose the selection method. Therefore, iTrain will randomly select one of the blocks ahead. If it selects B1, it will see this combination. And if we look at our truth table, it says for this combination, iTrain may select a path that contains this block but never stops. So the train is allowed to pass through the block. So B1 can be chosen and the train passes through without stopping. If it randomly selects B2, it effectively sees this combination. And a quick check of our truth table. We see here it says iTrain may select a path that contains this block but never stops. The length test is redundant. So it's effectively the same as we saw with block A. iTrain can select the path, it will never stop, but the train is allowed to pass through. Let's see if that is actually what happens. So I need to reinstate the weight for B2. We should be on 50% chance of a weight. So that looks okay. Press the OK button to make sure the settings are saved. So what we're expecting to see is sometimes B2 will be chosen with a weight. We will never see B1 chosen with a weight, but we could see B1 and B2 chosen as pass-throughs. Let's see if that's the case. So click the start button. This first one, we're seeing that it is a pass-through of B1. So the weights are not active when iTrain chose the destination block. The configuration effectively looks like this. iTrain then randomly chose B1 and it is allowed to pass through. Let's see if we can bring up one of the other variations. That's the same one, and here we go. So B2 is chosen with a weight. We can see that because it is an orange box, and down here we are showing B2 as the destination block. So the other option we expect to see is B2 as a pass-through, and there we go, B2 as a pass-through. So that is operating as we expected when the percentage chance of a weight is less than 100%. Now the other interesting thing to note is what is happening in the info box down here. When B2 is selected and the weight is active, we will see B2 displayed in the box down here. So that happens for the 50% of the times that weight is active. For the times when weight is not active, when I press the start button, you'll see that the two block names quickly flash up in the info box and then disappear. Let me show you. So I'm going to press the start button and you're going to look at the info boxes down here. So I press the start button now. This time it was when a weight was occurring, and we've got the solid B2 indication here. Now let me try and see if we can bring up one of the other variations. So press the start. Did you see that? Very quickly it showed B1, then B2, and then disappeared. And what is happening there is iTrain is showing us iTrain has reached this point and is trying to make the decision about which block to use, B1 or B2. Now I can effectively slow that process down by changing the block selection, or the block reservation, sorry. So if I go to train types and we click on the local passenger, which is what D6510 is, currently the reservation count is set at 2. I'm going to change that to 1, click apply and OK. So now when I press the start button, it reserves one block ahead, and what we're seeing here, because the reservation has reached the turnout, we're seeing here that iTrain is trying to decide between block 2 and block 1, and the order that it is displaying here is saying I'm going to try and choose block 2 first. If I can select it, then that's the block I will choose. If not, I'm going to choose block B1. So the order that it shows here is telling us a kind of a prediction of what block it's going to choose first. So I'm going to predict that iTrain is going to choose B2 as a pass-through. Let's double click the feedback and see if that's the case. And yes, there we go. Let's see if we can bring up another version. I first need to move this back into the start position and then click OK. Well, that's brought up the same one as last time, so let's try another. Right. So this time it's saying B1 first and then B2. So again, my prediction is that this will be a pass-through and the block it's going to choose is B1. Let's see if that's the case. Yep, pass-through and B1. So there you are. I hope that was of interest and gave a little insight into how iTrain is thinking when using automatic routing without a route, and that it demystified the behavior of iTrain when the percentage chance of a wait is less than 100%. In the next tutorial, we'll be looking at the station properties again and looking at the options tab and seeing what this threshold parameter is all about. So I hope to see you then, and remember, before you go, please take a second to press the like button. It keeps me motivated to create these tutorials. See you in the next one. Cheers.